All right. Today I'm going to go over the basic task number 3, token frequencies. These are listed on the Moodle, but I'll just go over the file quickly, the requirements. So task number 1 was to select 2 documents that you wanted to compare. Basic task 2 is to tokenize and process the tokens. Tokenizing, lowercase, removing stop words, limitizing. Task 3 is working with token frequencies. So we have, we'll use some basic Python functions in the NLTK module to calculate and sort token frequencies for each document, and we'll create some visualizations. So to submit task 3, you'll submit the Python script that you use to do this. You'll submit 2 bar plots and 2 word clouds. The script is available on Moodle under task 3, and I've got it here on my, also in GitHub. So in my academic internship folder, I have 3 folders: scripts, results, and data. So in scripts, I have task 1, 2, 3. So it's this task 3, token frequencies. So you'll download this to your computer. And then basic task 3 is to calculate and visualize frequencies of tokens. So first step is to import the tokens. So we'll import IO. I'm doing something different in the code here. I'm creating a variable called docname, which I can switch from Hamlet or Macbeth like this. Because a lot of several parts of this code are going to refer to the document name, such as the file name. So if I show you the GitHub file where my code is, right? Again, scripts, results, and data. In the data, I have Hamlet text, Hamlet tokens processed, and then the same for Macbeth. So the file I want to use is Hamlet tokens processed. That's what I created in step 2, in task 2. But notice that these file names are the same except for Hamlet and Macbeth. So when I'm defining the file name, I can just use this variable docname here and then add in the rest of the file name. I'm going to do this several times throughout these tutorials because I will need this for not just only for when I'm importing the file, but also later when I'm naming a graph, top 25 tokens in Hamlet or in Macbeth, and also when I'm saving the graph to the results file, task 3, top 25 bar plot, Hamlet or Macbeth, and it's a .png. Right? So I don't want to have to edit here to top 25 tokens in, and then the doc name is Hamlet or Macbeth, capitalize it to make it, to make it capitalized. So if I have this variable doc name, I can just use it anytime I need to use the name of the document. And I don't want to have to change that every single time I'm going back and forth between Hamlet and Macbeth. So this is how I do that. So let's start with Hamlet. And so I'll run this, and then my file name is Hamlet tokens process text. That's the data that I'm importing this file, the process tokens. Now I'm going to open that file. I'm going to read in those tokens, and I need to strip those tokens because they have the carriage return. So I'll show you if I don't do this and I just read in the tokens, they look like this. They have that carriage return. So I'm just going to go through the list and strip them. And now it strips that carriage return. So these are the 15,000 tokens that were in process tokens for Hamlet. So that's step one. And now step two, I want to calculate token frequencies. There's some reference here that you can look at. If you need NLTK, you can install it using pip. I've already done that. So you'll import NLTK and you'll import this module frequency distribution, freq distribution. Okay, so now we're going to use this function or this module to generate the frequency distribution of the tokens. So I will save this frequency distribution as a variable, freqdist, and to run this, I'll run the NLTK freq distribution on our tokens here. So I run it on tokens, and then we can look at the length of this object. And this is what that object looks like. So you can tell it's a dictionary, right, with a key and a value. The key is the token, and the value is the frequency. But it's a dictionary wrapped in this object, freqdist object, which may have some other attributes we don't know about. So if you want to output the items in this, we can reference them in a for loop. This X here will be apparently this X in freqdist, this will give us the key. So, and then when we print it, it'll print the key and also the value, which is freqdist with the key, which will give us the value. So if we run this, it should give us a list of 4,000 items, and it looks like they're sorted. So the highest frequency keyword or token in the document is Lord, and then King, have, I don't know, with a U, I guess. I'm not sure if that's have. Come, Hamlet, let thou shall good, or maybe honor. I don't know. Okay. So earlier when I ran this, there were actually several unwanted tokens. For example, some extra punctuation. There might be some other tokens. For example, if we go down this list, there's definitely stuff I don't want in here, like these brackets. You can get rid of those, like numbers. I don't know, some of these things we might ST, but some of these, when they got lemmatized, aren't very useful. It's letters and these things. So if I was going to do more than 25 tokens, I would probably go through this list and add more to the stop list. But I already earlier I opened up the extra stop words, and I added these things to the list, and then I ran task 2 tokenize again over both files to remove those unwanted tokens, and then I reran task 3. So now the frequency distribution here omitted those extra ones that I didn't want. Okay, so you might do that. Run task 2 again with that appended stop list, and then this data structure. I don't know exactly what this data structure is besides a dictionary, but I want to be able to manipulate the sorting. I want to be able to sort the keywords by the frequency, and you can't sort a dictionary by its values. So a dictionary is not a sortable data structure. So I'm going to convert these to a list of tuples, which looks like this. It's a list of tuples where the first element of the tuple is the token and the second element is the frequency. So I'm going to make a list comprehension on frequency on freqdist, and here, just like above, when I output this, in the tuple, the first element is going to be the token, the second element is going to be the frequency. And I'll save this as freqdist tuples. And when I run this, it has the same number, 4,318 tokens. And if I output this for Hamlet, we can see these are the tokens and frequency. And now, although these are sorted already, it looks like I can sort them just to be sure. Sort tuples by token frequency. So I want to sort this list by the second element in the tuple, right? By that 216. So I can do that using sort on the list, freqdist tuples. I can sort using a key, which is for lambda x element in the list, the one index of that element. So for each tuple, that's like an x, and then x index 1 is going to be the frequency, and that's what I want to sort by. So I can run this and then sort. Now it looks the same as this because it was sorted already, but if you want to, I can prove it to you. We can change reverse to false, and that will sort it from least frequent to most frequent. Right? And then I can change it back to true to make it in ascending order. Okay, so Lord 216, King 180. All right, so that's step 2. I have calculated token frequencies, and they're saved them in this list of tuples. Now, I want to visualize the top 25 keywords in a bar plot. So I will take the first 25 tuples using this indexing, and I'll just call that top 25, and these are the top 25 in order. Some of these, have the same frequency, like 107, 71. These are tokens that have the same frequency. If you also wanted to sort them alphabetically, you could sort them first by index and secondly by alphabetically by the token. So to do that, you would create a key, which is a tuple, where the first thing that you sort on is the frequency, and the second thing you sort on is the token. And so we can run that. And now you can see, let's see. The reverse is true here, is meaning it's going to give these in reverse alphabetical order. So sir is right, comes later than may alphabetically. So if you want the numbers to be in ascending order, but you want the keywords to be in descending or alphabetical order, then you can also make a tuple here to say this. So the first element will be reversed to true, which is in descending order, and the second element will be, which is the token, will be false, so it's in ascending order. Oops. Is it a list? Maybe it's a list. I'm gonna pause. Okay, I thought we could make a list out of reverse, but we can't. So, but there's one trick we can do is inside the tuple where we choose the the keys. For the numerical values we can use negatives to make it ascending or descending. So here, if we make the frequency negative and then take the token alphabetically. If we do this reverse false, that will give us ascending order, but for negatives here, so it flips it. You can play around with this. This is probably, it's more than we need, but this is a trick to allow you to sort by number in descending order and alphabetically in ascending order. So you can see when the frequencies are the same, the words are ordered alphabetically, H, L, S, T. So anyways, all right. All right, so we're taking the first 25. Then to make a bar plot, we need values for the x-axis and the y-axis. So the x-axis are going to be our tokens. So I'm going to create a list of the tokens, which is for each tuple in top 25, it's the first element. And then for counts, it's the second element, the frequencies. So I'm going to create these, and then we can look tokens. The tokens are the top 25 tokens, highest frequency tokens, and the counts are their corresponding frequencies. Now we're going to make a bar plot in Python, using Python. You'll need to install NumPy and matplotlib if you haven't done that already. And then we're going to import NumPy and matplotlib pyplot as PLT. So these are MP and PLT are just aliases for NumPy and matplotlib pyplot. So then we're going to create the figure, which is plot figure and define the figure size. And now we're going to run this code all together, which creates the bar plot. So we have this figure. Oh, sorry. The bar plot will be top 25 tokens for the X values, top 25 counts for the Y values. The colors of the bars will be blue and the width will be 0.4. The X label is tokens. I'm rotating the words on the X-axis so that they are 90 degrees perpendicular to the X-axis. The Y label is frequency of tokens here, and the title is top 25 tokens in whatever the doc name is. So here it's Hamlet. I'm going to capitalize that so it should show top 25 tokens in Hamlet. And then once I have this plot ready, I'm going to save the figure to the results file, and I'm going to call it task 3, top 25 bar plot Hamlet.png at a resolution of 400 dpi. So this line will save the file here in results. Top 25 bar plot Hamlet, it'll be this one. And then I'm going to show it. So let me run that. And you can see it's changed, top 25 tokens in Hamlet. And these are the values. Now, if I didn't do this, right, if I just left the rotation at the default, you'd see the words would run together. Right? And so in order to avoid that, you can do it as like, if you want, you can do it like 45 degrees, that might work, right? Or like negative 45 degrees, like that. But I'm just going to do them as 90. Okay, and then this saved also to this file here. You can open that up. And there's the PNG file. So that's that. Okay, so that's step 3. We made a bar plot for Hamlet. Now step 4, I want to create a word cloud, also using the top 25 keywords. Python does have a word cloud module called word cloud, and here's some information about it. However, it requires C++, Microsoft C++ virtual C++, and it's messy. It's hard to, it takes up a lot of disk space and it's hard to install. So it's not simply, if you try this pip install word cloud, probably it will throw an error. Here's some more code. So we're not going to do this. Instead, we're going to use a web-based app called wordclouds.com. And I'll show this to you. This is the website, and so you import the word list from a CSV file. You can choose the shape. You can choose the fonts, the direction, the colors, a lot of options, and you can also save it as an image or other formats. So this is a great site to use to create word clouds. This is one that I created earlier from Macbeth. But in order to make these word clouds, here, if you import from a CV, you drop a CSV file here or browse, and you can see there provide a download sample CSV file, so you can format so you know how you have to format your data. So I've downloaded that here. This is what their sample file looks like. It's a CSV file, and they're separating on these semicolons. So if we go to data, text to columns, delimited with the semicolon, then you can see this file needs to have 4 columns: weight, word, color, URL. The weight is the size or the weight of the token. The token will be here. The color, you can define the colors here as hex codes for each color, and you can also attach a URL if you want to, which will create a hyperlink in the word cloud. So I will assign colors, but I'm not going to do URLs. You could try that if you want. So this is what the sample file needs to look like. And in order to create this, I'm going to use Python pandas back in our code. So here, I'm going to go with the web-based app, and so I'm going to import pandas, and then I already have the weight and word columns. Those are up here. I already created those for the bar plot, these top 25 tokens and counts. So let me just put these in here. Word will be the tokens, and counts will be, actually, so weight will be the counts. Right, so we've already seen those. And the word will be the tokens. So I have these two already. Now what I need is the color. So to create the color column. So first I want to tell you about hex color codes. So you can look here at this site. On this website, you can pick any anywhere, and it will give you the hex code for that color. So the hex code is you can code colors using 3 dimensions, HSL, which is like hue, saturation, and light, I think, and then RGB, which is red, green, blue, 3 dimensions, or hex. So you can encode, you can pick any color you want. You can use a color picker. Again, here's the hex. Anywhere you click, right, you'll get this hex. Or you can use a color chart. See all the charts. Wherever you click, it'll give you the hex code for the color you want. So I chose purple as this hex, and gold, which is this hex. I made them lowercase. I don't know if that's necessary or not. But anyways, I'm saving these hex strings as a variable. And then here, I'm taking the list purple and gold, multiply it by 12 times, and adding one more. So it'll be purple, gold, purple, gold, purple, gold, purple, gold, like 25 times, because I have 25 tokens. And then if you run that, this is the hex for purple, gold, purple, gold, purple, gold. Right? So it's going to show every other word as purple or gold. Okay, so those are the colors. And then for the URLs, I'm just going to create a null string and multiply that 25 times, right? And that's going to look like, not very exciting. It'll look like that. So now I've got my 4 columns. I've got my weight column are the top 25 counts. My word column are the top 25 tokens. Color are the colors, and URL, the URL. And you can use a dictionary to create a data frame in Pandas where the key is the column name and the value are the values of that column. So using this, can create a data frame called DAT, which has the same structure, weight, word, color, URL, as the sample weight, word, color, URL sample file. So now all I have to do is export this. Well, you can double check the data types. So weight is an integer, and then these are strings, they're objects. Okay, so I'm gonna export this not as an Excel spreadsheet, but as a CSV file, because remember this word clouds requested importing from a CSV. So Pandas has an export function to CSV. It's just like Excel, or almost just like Excel. I'm going to export that to my results folder, and I'm going to call that file task3 word cloud data Hamlet, right, using doc name and a .csv suffix. And then I'm going to index false. This is important because this file does not accept a separate column, right? If the index is true, it would look like this. You would number the rows, right? But we don't want that because this website doesn't recognize that. The first column needs to be weight. So it's important when you're creating the CSV file that index is set to false, so you don't index those rows. And then you run that, and that will create this file here, task3 word cloud data Hamlet. And if you open that up, it's an Excel CSV file, and it looks like this. Right. So this is the perfect formatting for the word cloud. So we're going to take here, we can import from CSV, or we can just drop and drag here. So I dropped and drag, and you see these are my tokens, and here are the colors, but you can see it adjusted the weights because I guess it's using weight on a scale of like 1 to 100 or whatever. So I'll just, and it's 25 words. So that looks good. Everything looks good. I'll just apply this. Okay. And you can see there's Lord, King, right? This is our Hamlet one. let's change the shape just for fun. What shape do we want? Hamlet was a prince. I guess he became a king. So let's give him a crown. I think we have king. Maybe this one. Right. You can see the font are small, so they're not filling the object. So you can increase the word size like this, or even more. Right. So it's, I mean, you can play around with these. I don't care like how you make it. If you want the fonts, you can choose, you know, you can remove or add fonts if you want. Right? So if you only want like one, it'll do it all in one font. Right? But if you want it kind of mixed, you can add a font. Um, right? So you can play with this. Um, the direction you can play if you want them all like, you know, diagonal and vertical, or just a random. So you can play with this. And when you're done, then just export it, save as an image. And I save that also here as task 3 word cloud Hamlet. So I can open up that as saved it as a JPEG. And this is what I made earlier. So there's your word cloud. If you just want a general shape for the word cloud, you can use, I think just use this. And then it'll just fill a square like that. So that's what I did for Macbeth. It's just a square. Maybe you can change the dimensions, I don't know. Colored shapes, maps. I guess Denmark. Hamlet was the king of Denmark, so, or is that DE for Deutschland, or is that Denmark? I can't really tell. That's like all of Europe. That's Delaware. I don't know if that's, let's say that's Denmark. What's Germany? Anyways, so you can play with that text. You can upload your own shape. Okay, so you can play with that. All right, so back here, uh, so once you've finished the word cloud, right, that's everything. So then you'll upload your script, you'll upload your bar plots and your word clouds. Now we just did Hamlet, so if I want to do Macbeth, I just comment out Hamlet and uncomment Macbeth, and I can run this, and then now I've got 10,000 tokens, right? And the tokens are tragedy Macbeth. So I've opened the Macbeth file and I just run this again, right? And here are the distributions. This looks like it was a Macbeth lemmatized, but I've got Macbeth down here earlier, lower as well. King on so here are the lists. Here are the tuples sorted. Right. Here are the top 25. Here are the tokens and counts. Here's the bar plot. right? Now for top 25 tokens in Macbeth. And if I run this, I'll get the same. I'm using the same colors, but you could change the colors if you want. Now here's the DAT file for Macbeth, but the data frame types. Okay, and then I export it, and that's exported here for the task 3 word cloud data for Hamlet, and Macbeth, and then I just do the same thing, make the word cloud. So that's task 3. So you'll upload a total of 5 files. You'll upload the 2 bar plots, the 2 word clouds, and this script that you used. I have some bonus tasks here. I might do these, include these as the advanced tasks. For example, because we want to, what if we want to compare 2 documents? So in the bar plots and the word clouds for each document, we could highlight words which appear in the top 25 of both documents. For example, do we have any overlaps? So you can see like king, come, shall, thou, this. A lot of these words are duplicated. So it would be interesting if we make like, we could combine the tokens of the 2 documents also into like 50 tokens, but with some overlap. So it might be less than 50. And then we can create one combined bar plot and one combined word cloud. And then we could color the bars or the words where we color code those tokens according to whether they are in document 1 only, document 2 only, or both documents. So I actually might do this as an advanced task, like task 4 or 5. I'm not sure. We'll think about it. So that's all for task 3 though. And let me know if you have any questions.